Voyager 2, launched in 1977, was never supposed to last this long. More than 12 billion miles from Earth, it has journeyed far beyond the realm of the planets, deep into the interstellar void. This tiny spacecraft, no larger than a compact car, has outlived expectations, surviving the harsh vacuum of space and continuing to communicate with Earth, until recently. Then came something astonishing. A faint but undeniable signal was picked up, something so subtle, it took the most sensitive instruments on Earth to detect. And what it conveyed wasn't just a sign of life from Voyager 2, it was a warning. The kind that demands immediate global attention. This signal wasn't just static or routine telemetry. Analysts at NASA's Deep Space Network detected a highly unusual pattern embedded in the transmission. At first, it was dismissed as a glitch. After all, Voyager 2's onboard systems are nearly 50 years old. But after decoding the sequence, engineers realized it was transmitting a clear message. Not in words, but in data. The information pointed to drastic and sudden changes in the space environment far beyond the heliopause, the boundary where the solar wind from our sun yields to the interstellar medium. And these changes were unlike anything Voyager 2 had ever encountered in its long journey. What Voyager 2 detected was a massive spike in cosmic ray activity and a sudden drop in interstellar plasma density. These aren't just numbers, they're signals of something significant, something shifting in the structure of space itself. Some scientists believe this could point to an approaching shockwave, possibly the result of a long-predicted supernova explosion finally reaching our sector of the galaxy. Others think it may indicate a previously unknown interstellar phenomenon, one that could have cascading effects on our solar system's protective bubble. The heliosphere, inflated by solar wind, acts as a kind of shield against cosmic radiation. If that shield collapses or shrinks due to changing interstellar conditions, Earth could be exposed to levels of cosmic radiation far beyond what we're used to. That means increased cancer rates, compromised satellite systems, GPS disruptions, and even failure of power grids. It's not science fiction, it's astrophysical cause and effect. And Voyager 2, floating alone in the dark, just may have given us our first early warning. NASA scientists quickly convened an emergency session, coordinating with astrophysicists across the globe. The last time something remotely similar happened was in 2012, when Voyager 1 crossed the heliopause. But even then, the signals were gradual, expected. This time, the data suggests something abrupt is coming. Voyager 2 has, in a sense, stumbled into a storm that we didn't even know existed. And as data continues to trickle in at the speed of light, Earth-based observatories are turning their telescopes toward that mysterious direction, looking for clues. But here's what makes it even more unsettling. A review of past data revealed that Voyager 2 had been detecting subtle changes for months, small anomalies in magnetic fields, unexplained bursts of particles, but the signals were so faint they didn't raise red flags. Only now, with the full context of the recent transmission, do those earlier signs seem to form a pattern, an escalating one. It's as if Voyager 2 has been trying to tell us something all along. We just weren't listening carefully enough. The timing is eerie. Just as solar activity ramps up here in our own system, with the sun approaching solar maximum, producing more flares and coronal mass ejections, interstellar space seems to be getting more chaotic too. Could these events be related? Is something out there disturbing both the interstellar medium and our own solar dynamics? Some researchers think it's possible. If a shockwave or anomaly is traveling through space, it could simultaneously compress the heliosphere and agitate our sun, causing increased solar storms and auroras on Earth. Even more curious, Voyager 2's instruments registered a brief directional pulse in the magnetic field, a kind of ripple that doesn't match any known solar or interstellar pattern. One theory suggests it could be the gravitational echo of something massive passing nearby, something too dark to see, but too influential to ignore. Could this be a rogue planet, a dense cluster of dark matter, or something even more exotic? The data isn't definitive yet, but it sparked a flurry of research papers and debates within the scientific community. The signal from Voyager 2, though faint, is now being studied like a forensic artifact. Every bit of telemetry is being reanalyzed. Because once a spacecraft is that far out, it's not just a probe anymore. It's a time capsule and an early warning system. And if this tiny craft, built with 1970s technology, has just flagged a cosmic event heading our way, then humanity owes it to itself to pay attention. Astronomers have already begun comparing Voyager 2's findings with data from Earth-based and space-based observatories, including the James Webb Space Telescope and ESA's Solar Orbiter. The results so far are inconclusive but deeply intriguing. Certain stars in the region Voyager 2 is approaching appear to have subtly dimmed, as though something large, perhaps a dust wave or even a shock front, is passing through space between them. Is this the precursor to a galactic event on a scale we've never witnessed? Meanwhile, back on Earth, the geopolitical implications are also being discussed. If Voyager 2's warning proves accurate, global communications, satellite infrastructure, and even military systems could be vulnerable. Space weather forecasting may need to be revised entirely. Suddenly, the quiet, distant messages from a 46-year-old spacecraft have taken on a new urgency. And the world is listening. Even beyond the scientific and practical concerns, there's a philosophical weight to this moment. Voyager 2, one of humanity's farthest emissaries, is still doing its job, warning us from the edge of the void. It reminds us how fragile our place in the universe really is. That even in the vast emptiness of space, danger can come not with a bang, but with a whisper. The next steps are clear: more analysis, more observation, and more preparation. If Earth is about to pass through a region of increased cosmic turbulence, then our atmosphere, satellites, and even human health could be affected. Precautions must be taken. Emergency protocols for satellite hardening, radiation shielding on the International Space Station, and power grid safeguards might need to be reevaluated. But there's another layer to this story. Voyager 2, while drifting in silence, may not be the only probe sending warnings. Voyager 1, which is even farther out, has also recently reported anomalies. Although the data is incomplete due to its degraded antenna alignment, what little it has transmitted shows signs of similar plasma wave disturbances. Could both spacecraft be encountering the same interstellar phenomenon? If so, it means this isn't a localized event, it's widespread, potentially encompassing a large swath of space approaching our solar system. This convergence of data from two spacecraft on opposite trajectories strengthens the case that what's happening is real, not just a fluke or malfunction. And it raises deeper questions about how well we understand our cosmic neighborhood. After decades of thinking of space as mostly empty, we're now beginning to realize it may be more dynamic and more dangerous than we assumed. Meanwhile, ground-based magnetometers in the Arctic and Antarctic have started picking up minor fluctuations in Earth's magnetic field, correlating with the timing of Voyager 2's last burst of data. These are small, almost imperceptible shifts, but again, when cross-referenced with the spacecraft's data, they raise alarms. Could this be the start of geomagnetic effects triggered by changes in the heliospheric boundary? We've always known that space is not truly empty. It's filled with plasma, radiation, dust, and invisible forces. But now, thanks to a small spacecraft launched when Jimmy Carter was president, we're getting a real-time lesson in just how interconnected everything is. One shift beyond the boundary, and effects ripple all the way back to Earth. And Voyager 2, old, distant, but persistent, is doing what no other machine has done. It's telling us that something out there is changing. Something we didn't expect. Something we might not be prepared for. The question now is, will we listen in time? While Voyager 2's transmission has stirred scientific urgency, it has also reignited public fascination with deep space exploration. Social media platforms, forums, and news outlets across the globe are buzzing with theories, speculations, and doomsday scenarios. But behind the noise, the scientific community is taking real steps. Every observatory capable of monitoring cosmic radiation, magnetic field shifts, or interstellar matter is now on high alert. This is no longer just about Voyager 2, it's about our solar system's interaction with the galaxy around it. NASA has reassigned teams to specifically analyze data from both Voyager spacecraft. These scientists are poring over decades of telemetry, looking for patterns and signs that might have been overlooked. Parallel teams are working on computer simulations, attempting to model what kind of cosmic event could cause the fluctuations Voyager 2 has reported. Could it be the shock wave from an ancient supernova reaching our system after thousands of years? Could it be a dense cloud of interstellar gas altering the pressure around the heliosphere? Or is it something entirely unknown? One simulation, still in early development, suggests that a rare alignment of interstellar magnetic fields could be compressing our heliosphere from one direction. This compression could temporarily thin the shield that protects Earth from galactic cosmic rays. If true, it might explain both the sudden increase in radiation Voyager 2 has detected and the concurrent anomalies experienced by Voyager 1. But there's a more dramatic hypothesis being floated as well. Some researchers have suggested that a form of interstellar shock front may be sweeping across our galactic neighborhood. These shock fronts are like invisible tidal waves of energy created by ancient cosmic explosions or the merging of massive stellar objects. They travel vast distances, and though they may be diffuse by the time they reach us, their effects on our delicate solar boundary can still be significant. Voyager 2, sitting right on the frontier, would be the first to sense the wave's arrival. The possibility of a shock front brings a cascade of concerns. For one, it could mean months, or even years, of increased cosmic radiation exposure on Earth, particularly at high altitudes. Airline flight crews, astronauts on the ISS, and satellites would all face heightened risks. GPS systems could experience momentary disruptions. More concerningly, increased radiation could interfere with Earth's magnetosphere, possibly triggering electrical disturbances similar to the infamous Carrington event of 1859, a solar storm that disrupted telegraph systems and lit up skies with auroras as far south as the Caribbean. Scientists are now revisiting historical data to determine whether similar events have occurred in the past. Ice core samples from Antarctica and Greenland contain trapped particles that may provide clues. If there were previous interstellar disturbances, these records could hold the key to understanding how Earth was affected and how we might prepare now. Meanwhile, Voyager 2's signal continues to weaken. Its power source, plutonium-238 in a thermoelectric generator, is running low. Engineers estimate the spacecraft has only a few years left before it falls permanently silent. That's why every transmission is treated like a precious relic. Each bit of data is scrutinized, every anomaly logged. And each delay in response is a race against time. In a recent update, NASA confirmed that Voyager 2 had again pinged Earth, this time with a more stabilized signal. While the strange plasma readings continue, some of the erratic magnetic field data had returned to baseline levels, at least temporarily. Was this a sign that the shockwave was passing? Or just a momentary calm before another pulse? No one knows yet. Outside of NASA, international space agencies are also deeply involved. The European Space Agency has assigned its deep space antenna in Australia to aid in monitoring Voyager 2. China's FAST telescope, the largest single-dish radio telescope in the world, is quietly listening too. Across Japan, Canada, Germany, and India, instruments are tuning in. This has become a global effort, one of the most unprecedented real-time scientific collaborations in modern space history. Some have even proposed sending a fast-response probe, something akin to a space lifeboat, to reach Voyager 2's vicinity in the coming decades, either to recover it or gather data from the area it's currently navigating. While technically ambitious and decades away from execution, the idea itself underscores how seriously Voyager 2's warning is being taken. But there's another layer to all of this, a more unsettling one. Embedded within Voyager 2's data was a minor fluctuation in its transmission clock, something engineers hadn't seen before. Initially believed to be an error, further analysis showed it wasn't mechanical or software-based. Instead, it was environmental, suggesting that the space Voyager 2 is now traveling through may be affecting its systems at a fundamental level. This has led some theorists to propose that the spacecraft is nearing a region where space-time itself might be slightly warped or distorted. Not enough to tear reality as we know it, but enough to alter electromagnetic signals. Could this be caused by gravitational forces? A dense object like a neutron star? Or a relic from the galaxy's violent past, finally drifting into our region? Others are more cautious, pointing out that this could be the natural degradation of a decades-old system. But even skeptics admit that the data is strange, too strange to ignore. It has even led to renewed discussion of previously fringe theories, like the possibility that Voyager 2 has encountered a region of spacetime with anomalous properties, similar to theoretical wormholes or warped space sheets suggested by Einstein's equations. Despite the uncertainty, one thing is clear: Voyager 2 has given us a final gift, a window into a realm we can barely comprehend, a glimpse at the boundary between our solar system and the true interstellar abyss. And its message, though cryptic, is urgent. Prepare, observe, and don't underestimate the cosmos. Humanity, for all its technological prowess, is still just beginning to understand the forces that govern our galaxy. For now, we are lucky to have eyes on the edge, drifting silently across space, still doing their job after nearly half a century. But the day will come when Voyager 2 will fall silent. Its signal will fade, its instruments will freeze, and it will become a relic, floating forever between the stars. Until then, every bit of data it sends is more than science. It's a message in a bottle. And perhaps, its final transmission is the most important message any machine has ever sent.